and I hope you all can see my screen now. So the training has been organized for you guys by PyNet Labs, and we're going to have this training as a weekend only training where you all can attend this training every Saturday and every Sunday at the same time that we are currently handling the training. Now, talking about myself, as I told you, my name is Abhijit Bakle, and you can call me AB. I'm gonna be the instructor for this training. And talking about myself, I've been delivering corporate training since last 8 years now, and as of now, I have my key expertise in routing and switching domain, in which is now enterprise network. Then I have my key experience in security domain, in data center environment, and then I recently have been delivering a lot of trainings in network automation as well. So as you all are aware that there is a lot of boom in this network automation industry, we have kind of catered the same thing here, and we have been delivering network automation training since long time now, and that's the USP of PyNet Labs, where we are looking forward to cater the best training that is possible for you guys over there. So that's why we have came up with this very fundamental knowledge training, which we are going to cater the official curriculum of CCNA. So, though you guys are aware about some of the, I would say, SOPs of this particular training, the training will be conducted every weekend. So it's weekend only training, and I'll see you guys on every Saturday and every Sunday. And the timing of this particular training, as you like, there is different time zones, so I won't mention that. But I would say every day we are going to have this particular training for 4 hours a day. And this particular training will involve theory, plus it will also involve labs during the training itself. So you're gonna get yourself introduced with the knowledge of theoretical, where we will start from the very scratch of networking, and then I will take this particular class further into all the concepts that are mentioned in the official curriculum of Cisco CCNA training. Right? If you face any difficulty during the training, you can directly put your messages, or if you can directly put your doubts into the chat session, or you can also put that into the Telegram handle as well, which has been shared with you. Otherwise, if you personally would like to get in touch with me, you can search on any of the social media platform, be it LinkedIn, be it Facebook, be it Instagram. You can just search for my name there, and I will just pop up there. Okay. So you can see that particular profile of mine over there. You can follow me over there and reach out to me. Otherwise, for any other queries or any other discussions that you would like to have, you can reach out to the Pasha as well, or Nitish as well. So these guys can actually help you to solve your queries or difficulties. So that's all I would say from my side, and I will basically move on to the conceptual knowledge of CCNA. So if we talk about CCNA, everybody is familiar that CCNA stands for Cisco Certified Network Associate, right? Cisco Certified Network Associate. And earlier, if we talk about the certification model of how Cisco used to deliver certification, then I would say that the certification used to be delivered in a way. There were three different type of certifications. So I can say we had CCNA as the first level of certification. If we divide it into different level, then the second type of or second level of certification was CCNP, and the third level of certification was CCIE. And there were different tracks that were associated with these certifications. So I can say if we talk about tracks, then we had routing and switching as one of the track. We had security as one of the track. We have data center as one of the track there, right? Then we had different other tracks as well, be it collaboration, be it service provider, or be it cloud or anything else. So there were different tracks that are available into Cisco's official certification. And if we talk about, I would say, different levels, then you could do CCNA in routing and switching, you could do CCNA in security, you could do CCNA in data center, collaboration, and so on. And then once you become CCNA certified in specific domain, then you would go for your professional level certification. So if you're done with your CCNA in routing and switching, then you will go for CCNP in routing and switching, and then CCIE in routing and switching. That's how you actually clear all the links there, or clear all the certification levels there for a specific domain. And you can even go ahead and do the certification in multiple tracks as well. For example, if you become CCNA routing switching, you can also do CCNA routing, CCNA in security, or CCNA in data center. Or once you become CCNA and CCNP both in routing switching, you can do that for security as well. Or even all these tracks can be repeated for multiple, multiple domains as well. So when we say that this is a certification model which Cisco executed for almost now 30 years or 25 years. But on, you can say, February 24th, 2020, this is exactly when Cisco announced new line of certifications. Cisco made the biggest change in the history of their certification model. And now the CCNA that we look at, it is not associated with any of the tracks there. So we just have plain CCNA, okay, which stands for Cisco Certified Network Associate. And then you have two other certifications, that is CCNP and CCIE. And then the CCNP and CCIE are divided into different tracks. So the routing and switching that you actually used to see has now become something called enterprise. And then the other domains still continue to exist. So where you have security, where you have wireless, where you have data center, where you have service provider, where you have collaboration, and so many others. So now you cannot do CCNA for any specific type of domain there. Where you start get specialized with the type of domain that you have is from CCNP itself. So you can do CCNP in enterprise, CCNP in security, CCNP in wireless, and so on. Or you can also do CCIE in enterprise, CCIE security, CCIE in wireless, or so. Make sense? But you cannot do CCNA which is specifically binded towards any track or so. It is independent of any of the track that is available. And if we talk about how it works, so CCNA, again, it's an individual exam, which will be about like 2.5 hours of exam. And if you get 85% of score there, then you will basically be having your CCNA certification. And once you're done with your CCNA, then you can move on with the CCNP. Now, if I talk about CCNP there, then in CCNP as well, if we talk about old method, not the new method, then old method, for example, I want to pursue CCNP in routing and switching. Then there were 3 exams that were associated with this certification. First, you had to give the CCNP route exam. Then second, you will be pursuing the switch exam, CCNP switch. And third, you will be going for the T-shoot exam, troubleshooting exam. And if you pass all of these, then and then only you can actually become CCNP certified or CCNP routing and switching certified. And even though, like, if we consider the same type of scenario for other certifications as well, like CCNP in security or CCNP in data center also, this is how the thing was. So you need to give that particular like dedicated number of exams there. Like CCNP security had 4 different exams that needed to be passed in order to become CCNP security. But this is not the case now. So what Cisco have done, if you want to become CCNP in, for example, let's say enterprise. So in order to become CCNP enterprise, only 2 exams needs to be attempted. So the first exam, in order to become CCNP Enterprise, will be the core exam, which is ENCOR or ENCOR. And every module in the new line of certification has its core exam there. So if we talk about security, it has a core exam called SecCore. If you talk about DC data center, then it has a DC core. If you talk about service provider, it has SP core. So every module or every track has their own independent core exams associated with it. Then the second exam will be called as concentrated exam. And this concentrated exam can be chosen from the list of different concentrated exams that are available. For example, the first option that you have is to take the Advanced Routing Services exam, which we call it as NRC. Or if you can go up with the design exam or the SD-WAN exam. So you have an option to choose an SD-WAN exam as well. You have an option to choose the design exam as well. Makes sense? You have an option to choose some other type of exam as well, be it like wireless implementation, okay, or wireless design. And there are different almost, there is also an option called an auto, which is for automating the enterprise network solutions. So all these exams are part of the concentrated exams. And what you need to do, you just need to pick any one of this exam of these exams. So if you pass NCORE, for example, and then if you pass NRC, you will become CCNP Enterprise Certified. Okay, if you pass NCORE and N-Auto, you will become CCNP Enterprise. You will pass NCORE and SD-WAN, you will become CCNP Enterprise. Just like that, what you need to do, you need to pass a core exam and you also need to pass one of the concentrated exam that is available there. Makes sense? So just like that, the same thing is available for every other type of module there. So where in security you can do that. Yeah, you can, if you want to do security, then you can actually do that core exam of security and concentrated exams of security as well. Make sense? So when we think about that in that way, then how it works is you don't need to be CCNA certified in order to become CCNP certified, but individually you can actually go ahead for the CCNA certification first. Okay, consider this as the first step if you're starting your career with networking, and then go for the CCNP Enterprise certification. Okay, these two certifications are the most recommended certifications from my side, I would say, because these two certifications clears most of the fundamental knowledge of what you actually need in order to get a job, in order to step up in your career, or in order to understand networking in a deep manner. Makes sense? So CCNP can your guiding hand there, and then after that you can actually move ahead with CCNP certification. You get that? So now as you're familiar with this CCNP certification, then there is a new line of certification that has actually came out. Because if you talk about different streams that are available, then you have routing and switching, which is now enterprise. Then you have security, then you have data center, then you have service provider, then you have different other certification. But there is a new line of certification that they have announced, which is called as Devnet Certifications. Yeah, CCNP Cloud is not there in the new exams. It was there in the old exams that you could do CCNA in cloud, CCNP in cloud, but they have completely removed this cloud examination from there. And those who had cloud examinations or those who had cloud certifications, they have got offered the equivalent data center examination or data center certification. So they are merged with data center and cloud is no longer available there. So if you want to, yeah, someone is asking if you want to develop a career in security, then I would recommend, or if you want anyone to go in a specialized track, be it like anything apart from enterprise, be it security, be it service provider, or be it something else, then I would recommend you to first finish your CCNA and CCNP enterprise, and then go for CCNP security. So whatsoever specialized track that you want to become, then you can actually go for the enterprise certification first and then jump into the specialized certification. That's how you can go ahead. Cool. So Cisco have came up with the latest certification, which is Devnet. And this Devnet is more of something called network automation. And what this network automation is, it means that in with the larger complexity of how network is actually growing in today's world, there is a need in order to, I would say, cater the need in a way that you should be able to configure, manage, and troubleshoot all the devices of your enterprise network with a centralized location. For example, you don't need to configure each and every device every time there is a problem. Or you don't need to go onto each and every device physically and configure the same. You should be able to automatically deploy the configurations, or the devices should be able to automatically resolve the problems that they have. So this DevNet track actually focuses on the same thing, on how you can actually implement network automation inside your network. Makes sense? And the certifications that are followed there is DevNet Associate, which is just equivalent to CCNA, but the content is different. And then there is CCDP as well, DevNet Professional. This DevNet Professional, however, covers the same type of blueprint where you have a core exam, which is called as Dev Core, and you have the other type of exam, which is called as concentrated exams. And these concentrated exams are nothing but the automation module that you will find in the concentration exam of every other track as well. So if you consider about enterprise, then there is an automation track called an auto. Then if you consider security, then there is sec auto. Then there is DC auto, right? There is some other type of exams as well. And every automation module is present at the concentration exam of the DevNet itself. So if you do dev core and if you do N auto, okay, then you become CCNP certified as well if you already have N core certifications. And then you again become DevNet professional as well, and enterprise professional as well, by just giving 3 exams. So you can give the first exam can be for N core, the second exam can be for dev core, and the third exam can be an auto. When you give all these 3 exams, you become CCNP in enterprise, and you become CCDP in DevNet. Make sense? That's exactly how the new line of certifications are working out here. And I hope you understand that how it actually works. So talking about these line of certifications, what we are going to do is we will make ourselves comfortable with the content of CCNA, and then we will start learning CCNA line by line. So let me just put my thing on charge, and we'll then resume with the same thing. Guys, I still can see some of you have turned on your cameras. I request you to please turn off your cameras. Alexander and Ibrahim, please turn off your cameras. Thank you.
Abhijit, you are on mute. Abhijit.
Yeah. So I hope you can see me now and you can see my display over here. Now, the concept that I'll quickly make you familiar with the content that we're going to cover in this particular training. So, if we talk about CCNA, then CCNA is divided into different tracks, or I can say different sections. The very first section gives you about introduction to networking or network fundamentals. Okay, so the first section will be introduction to network fundamentals, and then after that, after getting familiar with that, we'll be moving on with the second thing that will actually give you the things about IP addressing and subnetting. So we'll be spending a lot of time on getting to know about IP addressing, and we'll be spending a lot of time on subnetting as well, because this is key concepts that you actually need to be familiar with. And once you get familiar here, then we'll be moving on with getting to know about how to use networking devices. Okay, so I'll be giving you an introduction to what all are the devices that are available, be it routers, be it switches, okay, be it firewalls, be it load balancers, be it IDS, IPS security devices, and many others as well. So we'll be spending some time in order to get to know about what all these network devices does, and then we'll be implementing, like configuring the network devices. So we'll be spending some time on getting to know how you can configure the network devices with Cisco Internetworking Operating System. I'll make you familiar about how you can actually use Cisco's Internetworking Operating System in order to configure something. And then we'll move on layer 2 services. So we'll get to know about different topics like VLANs, we'll get to know about how VTP works, we'll get to know about how trunking works. Okay, then we'll talk about how actually you can say HSRP or spanning tree protocol works, and various other layer 2 technologies. So we'll be talking about all those technologies there. And then we'll be spending some time on layer 3 services, where we'll be talking about different routing protocols. So be it routing information protocol, be it static routing, or be it dynamic routing in a way that we will get to know about EIGRP, OSPF, okay, and various others as well. But we'll be spending the lab, or we'll be doing the labs for each of this protocol that is available. And then we will be jumping off into security section, in which we will talk about access control list, in which we will talk about iOS security. And this iOS is not Apple's operating system, so it's I would say Internet Web Operating System security. Okay, and then we'll be spending some time on, you can say, IP services, where we'll talk about network address translation, and we will see how IPv6 is changing the game. And once we get familiar with all of this, then we will look at some of the security concepts even more. I'll give you an introduction to how DHCP concepts like DHCP snooping works, and how dynamic ARP inspection works, okay, and how port security works. And I'll give you an intro to VPN as well, virtual private network. And then the next section will actually focus on WAN technologies, and the last section will be focusing on automation. So we'll get a glimpse on how automation is actually done on different devices there. And these are going to be the pointers that will actually help you understand the flow of the class, and it will make you comfortable with what the content is going to be covered in this training entirely. Make sense? Great. Yes, CCNP is still an entry-level certification. All right. So as today we are going to discuss entirely about introduction to network fundamentals, and we will talk about what is a network, why do we actually need a network to be implemented in our production environment, and we will see how do we make like networks, small networks, by combining multiple devices together by using some of the services like IP addresses and so on. So and then we will see how OSI and TCP/IP model comes into picture. So to start the thing with a pretty exciting session, I hope you all are energized for this session. And here we go. Introduction to network or computer networks, whatever you say. So what is a network? Whenever you consider something in order to understand what actually is a network, then you, I would say, consider that this is one PC, and then you have another PC here. Now, if both of these PC wants to communicate together, how do they do that? They can actually send some traffic that, let's say this is a boyfriend and this is a girlfriend, and then BF and GF talk with each other in a way that, hey, sweetie, how are you doing? Okay, and this is a message that the boyfriend wants to send to the girlfriend by using one of the messaging application, let's say WhatsApp. Now, what are the requirements that you actually need to complete in order to fulfill that the message gets delivered to the girl? One of the requirement is the IP address should be configured onto the device. Then WhatsApp should be installed onto the device. The third requirement is internet should be on. Internet must be on there, right? And fourth, they must be in relationship. Otherwise, there's no point in sending the message, right? I hope you get the feelings. So when you actually want to send a traffic, that traffic contains a lot of feelings there and a lot of IP packets as well. So we can consider that the feelings will only get delivered only if it satisfies the conditions of IP addressing, only if it satisfies the conditions of networking and how the network should work. So you can say that the communication can work in multiple ways. The communication can actually work in a wired way or in a wireless way. Your feeling has the power to travel with wire as well and without wire as well. So if we go according to the wired communication, then you use different devices, or you can say you use different, I would say, communication standards in order to connect one PC with the other PC, right? And when you use those computers or mobile phones also, because most of the mobile communication happens wirelessly, where you can have a scenario like this is a mobile PC, and that particular or that mobile computer is connected with Wi-Fi, and that particular Wi-Fi might be situated inside your home. So this is your home, and that's your router, and your router is actually connected with another router, which is of ISP router, and the ISP can be anything. It can be something like we have very popular ISPs in India like Jio or Airtel or Vodafone or some others as well. In United States, or if you talk about some international ISPs, we have Verizon, we have Sprint, we have AT&T and others as well. So what do? You actually purchase an internet pack, or you actually purchase a broadband connection in your house, and then the ISP kind of gives you a cable inside your house, and that cable can actually be STP cable, shielded twisted pair cable. Okay, we'll be talking about different cable characteristics as well. But when that cable is given to you, this cable can actually either be two type of connections. You can have a copper connection there, or you can have a fiber connection, because there are most of the ISPs in the metro cities who actually gives the broadband connectivity over the fiber as well, to which we call it as FTTH, fiber to the home, right? So when you install this broadband connection within your house, then your router starts giving signals, be it wirelessly, or there can be a computer which is connected with the local area network as well by using wired connectivity like that. So there are different devices which are actually connected by Wi-Fi, and there are different devices which are actually using the LAN service, or they are connected by using the physical ports. So the router that you actually have in your house has a WAN port, okay? And in that WAN port, you will actually install the cable that is coming from the ISP end. And then after that, when you configure your LAN ports with the devices that you want to create connectivity with, you can also configure your wireless settings so that your router starts sending wireless signals to the devices that want to get connected, that wants to get connected with the router with wireless. Now, this ISP that we're talking about, let me just drag this topology somewhere down here. Yeah. So when we talk about this ISP, then this ISP might be or must be connected with some other devices as well. For example, this ISP is connected onto a WAN network, wide area network. And this WAN network is again connected to some other ISP, or let's say ISP2. And with that ISP, this is the house of your queen or princess or whosoever you're dating. And then there she is. She is connected with another router in her house. And then she is also using wireless communication to get signals from the router. But this router again is connected with the ISP2. And then you might have some physical machines connected with that router as well. So you can consider it somewhere that this is site A and this is site B. And the relationship that you're dreaming of can only be achieved if both of the sites are connected to the internet, I must say. So when we assume that you are sending some traffic from one PC to other PC, the logical scenario in our mind can be like this, that you have the direct connectivity and you are able to send traffic directly from one PC to other PC. This is what we assume, that if we open up our mobile phones, we open up any chatting application or social application, and then we type our message and then we send it to the destination, and it gets delivered. So this is how the picture is that you assume there. But this is not how it works, because there are a lot of devices that are in between. Whenever you're trying to communicate with some or the other way, then there are many entities that are actually connected with the device there. So this is how you communicate. You first will be reaching out to the router. Then the router will take you to the ISP, which is its gateway. And then you will be able to reach out on the entire internet, and the internet will route your traffic to the other ISP. And it is also possible that your girlfriend or your whosoever you are communicating with, that particular person is also connected to the same ISP. So whatsoever requirement is there, then the ISP reaches out, or the traffic reaches out to the ISP, and the ISP forwards that traffic to the destination. And everything happens in a way or in a specific way. And there is a lot and a lot that goes into your packet. It is not only your feelings that are constructed in a way or in a message or so. There is a lot of other things as well which goes around the network with your message. Make sense? And what are those things? Let me just drink some water. Yeah. So when we consider that you actually want to communicate with the devices there, we assume that this is how the communication works. The traffic goes from here, all the way here, all the way here, and then it gets delivered onto this device. Makes sense? but there is a lot of process that has involved or that is involved in it, and we call something as a computer network in a way, like in a standard definition, that whenever there are two or more devices that are connected together and they have been configured with the IP addresses, then we call it as a network. Assume that if we have a classroom, and in that classroom there are multiple people who are actually sitting, so you can say that this is a classroom, and there are 1, 2, 3, 4, 5, 6, 7, 8, 9, 2, 11, 12. So there are 12 people actually are sitting in that classroom. So we can call it a network of people or network of students. Just like that, instead of having these, I would say, people, you can have or you can assume that these are not people, these are actually computers. And just like that, you have multiple computers in a room. And when you connect all these computers together, then you call it as a computer network. Make sense? And this was kind of an old technology, or I would say this was kind of an old terminology where it was assumed that a network can only be created whenever the network is actually made up of computers. But nowadays, there are so many other devices. You can use your smartphones, right? You can use your laptops, you can use your iPads, you can use your tablets, you can use your home appliances, okay, you can use IoT devices, and you can use almost every appliance that you use, be it watches, be it even now they are like wireless headphones, gaming laptops, and so many other things that can actually be connected into the network or into the computer network itself. So it doesn't need to be any specific device that actually can communicate with the network, because in the earlier age it was only computers who had this superpower of getting connected with the network. But then with the evolution of the IT technology, you have almost every device now that can actually be connected to the internet, be it TV, be it television, be it your refrigerator, be it any home appliance, be it any, I would say, office appliance, be it any personal appliance, everything, almost everything can be connected onto the internet. But there is this way. Why do we actually use this internet? In order to exchange the information from one device to another device, or from one PC to another PC, or from one mobile to another PC, or any combination of devices. Make sense? So how does it actually work? Everything comes in a play when you actually think of it in a way that how networks were when they were actually created in the early age of internet, for example 1980s. Okay, if you think of network, that how it was in the early age of internet, then you can assume that there were different devices that were actually needed to be connected together. For example, there was a university, and it was a university project where lot of people a lot of people were using different resources. So for example, this is a university, and the university had 20 computers, and all of these computers was being utilized for the research purposes. So as they were being used for the research purposes, then they need to do some sort of other operations as well with the research that they're doing. For example, these 20 computers needs to print around I can say 20 pages per day of their research that they do. But the limitation was the university only had two printers. Okay, and you can say the two printers were divided, was one at each building. So the scenario was that sometimes some of the people would sit into a building and they could only use the printer that is available inside that building, but they could not use the printer that is available in some other building, because they would have to walk off from that building and then get into the other building and then reach out to the computer or the printer and then do their printing that they have to do. So this was one of the resource problem that was being faced. Now, what they did then, they initiated something that by using the network interface card, they could actually communicate with multiple or with the resources with the help of a network. And what they did, they kind of used this particular, or they kind of used each and every computer that they had, be it whatever, and they connected it with a centralized device which was called as a hub. So hub was a device which would actually connect each and every device together, okay, and be it like printer as well. So you had two printers there. These two printers can actually be connected onto the network. And then nobody would have to walk off to the internet to the printer physically, and then they will not be needed to print it out by themselves. What they can do, they can actually connect that particular printer onto the network, and then they can like give the instruction to the computer that printed, and by with the help of the printer being connected onto the network, they could actually print that particular paper from remote. And it was possible to also access the printer that was situated into second building as one of the resource that can be made available to the people into the first building. You get that with the help of a network. Just like that, when network started to grow, then there were four different campuses that were actually being connected with the network. So this was campus 2, then you had a campus 3, and then you had a campus 4. Make sense? So when you have this particular campus there, you could actually connect each and every campus together in this fashion. And then there were different research people that were sitting at different campuses, and they could actually exchange the information that they are working on. Do you understand that? With the help of a network itself. But now, here comes the major problem. In early days of internet, the solution or the most famous company that was actually selling the computer applications or computer systems was IBM, right? And IBM was a company which was actually selling most of the computers back then. But it was not like a thing that other companies were also not popular, because there were companies which existed like Dell, and Apple was also coming up back at that time. And people were actually looking forward to purchase devices made by the other companies as well. Now, what the problem was that if you want to put a computer in a network, then you would only be able to communicate with the computer of the same vendor. That was one of the requirement, or that was one of the limitation there. Because back then, the computers that were actually made by IBM were using a solution which was called as Devnet. And network interface cards which were manufactured by IBM computer could only, I would say, communicate with the computers or with the network interface cards that were manufactured by IBM itself. You get that? So which means that if you have a computer which is of IBM, let's say this is the computer that is IBM made, and then this is another computer which is manufactured by Dell, then you guys cannot actually communicate in a network, no matter like if your computer is fully capable of getting connected onto the network. Make sense? This is not possible. So how do you solve it? Then, as the requirement was kind of getting grown, and as organizations or standard bodies kind of realized that in order to make this network a bigger one, you actually need to have a standard, you can say, protocol suite, because there were different transactions that were being carried into the network. So transactions like using different protocols. The protocols were like HTTP protocols, the protocol were FTP protocols, be it the protocols of Telnet, okay, or be it SNMP, or be it some other type of protocols as well. So when you have all these different protocols, these different protocols were installed into directly into the NIC, network interface card itself. Make sense? So when you have this network interface card that can only be able to understand the protocol which is manufactured by one vendor. For example, if you have an IBM machine and if you have Dell machine, both of them are capable of like executing an FTP transaction. But the FTP that IBM understands is different than the FTP that Dell understands. Both of them were kind of different protocols there. Make sense? And just for the same requirement, when I would say researchers or when organizations kind of identified it, then they announced something that these type of communication should be made standardized, or whatever protocol you actually use, this protocol needs to be made standard step. And that's exactly when OSI model, or that's exactly when Open System Interconnection model came up, or which we call today as OSI Reference Model. And with the help of this OSI reference model, what happened in OSI, there were different, I would say, layers. So OSI model brought a concept to which we called as the layered approach. You understand that? And in this layered approach, there were different layers. So the layers that were involved was application layer, a presentation layer, then you had a session layer, a transport layer, a network layer, then a data link layer, and a physical layer. You get that? So you can have multiple layers over there, and every protocol that is out there will actually be a part of some or the other layer over here. So if you say protocols like DHCP, protocol like DNS, protocol like HTTP, were all kind of becoming part of the application layer. Where at network layer there was a very famous protocol called IP that used to work. At transport layer there was a protocol called TCP or protocol called UDP that was actually working. Make sense? At presentation layer, there were different job responsibilities that was given to presentation and session and data link and physical layer. So every other layer was actually, so all the layers that you have in today's world, every layer that is available there is actually part of this OSI reference model. However, this reference model is not something that we usually use in today's computer environment, but this is something that is referred in order to understand how it actually works. So what we are going to do here is we are going to get ourselves introduced with each and every layer that is available, and there is something which is called as encapsulation and decapsulation, and we'll be getting to know about what this encapsulation and decapsulation does, and then we will be understanding the fundamentals of OSI model and compare it with the new model competed with the OSI model, which is now called as TCP/IP logical model, and that's exactly the model that we actually use in today's world. So let's get ourselves introduced with what this particular model does. Now, do you remember I gave you an example that a boyfriend is looking forward to communicate with the girlfriend, right? So, when a message is sent from one end to the other end, then there is a process that is followed, and that particular process is called as encapsulation and decapsulation. So how does this encapsulation and decapsulation work? We're going to get ourselves introduced with that, with the same thing. So for the same thing, what you need to do, you need to understand each and every layer that you have here. And when you understand what each and every layer does here, then you would be pretty familiar with what and how the communication is actually done between the devices. So let's get started. As I told you that whenever the machine or whatever machine that you're working on tries to communicate with some or the other device that is available, then before leaving your computer, for example, that's the computer that you have, and then you are actually look connected to a router, and that router is connected to the ISP network, and then there is some resource onto the internet that you want to access, let's say youtube.com, and this is where the YouTube server is. So the communication will of course be in this way. But when your actually request, or when the request starts to leave from your computer and reach out to the gateway, it collects some of the information from your computer. And what that information is? That information will be according to the application layer that is available. And an application, so the information or the encapsulation is done from the top down approach. So first it will collect information about application, then it will come down to presentation, then it will come down to session and transport and network and so on. And once it reaches out to physical, then your data is actually sent onto the cable. Otherwise it just stays there in your computer and collects some of the information that is pretty prerequisites for initiating that communication. So when we say this, then at application layer, which is the layer number 7, we call it, because layer number 1 is physical, then 2 is data link, the 3 is network, 4 is transport, 5 is session, 6 is presentation, and the 7th one is application. So when we actually look at getting the data uh, ready for sending it over there, then the encapsulation starts at the application layer. And at application layer, it collects information about the resources, whether available or not. You get that? Meaning that, so see, can you use WhatsApp if you don't have the WhatsApp application downloaded in your phone? Or can you use Facebook? Or can you use Twitter? Or can you use YouTube or any other application if that's there? Can you access that particular application if the application is not installed in your machine? Would you be able to do that? You cannot do that, right? And why you can't do that? Because application is like the most important thing that you need to have if you want to, I would say, if you want to communicate with whatever thing needs to be done there. And how do you do that? So you go to the Play Store, you go to the App Store, or you whatever, wherever you will be able to download the application, and then you will see the information that you want to actually access. So just like that, if you want to reach out to the server of YouTube over here by making this type of travel, then your device needs to make sure that what is the resource that you're using, because that's the information that the YouTube will actually need to understand. So the device collects information from your machine at application layer, that whether enough resources are available or not. And if enough resources are available at the application layer, then it collects that information and moves out to the presentation layer. And when it moves out to the presentation layer, then at presentation layer, it does something in a way that there are some responsibilities that presentation layer handles, and those responsibilities are called as the process of compression and decompression. Compression and decompression is something that is taken care by the presentation layer. Meaning, But after getting to know that you have enough resources that are available at the application layer, then it will come down to presentation layer. And then at presentation layer, there can be multiple type of data that you actually want to access. And that data can be of a type that it is kind of an MP4 video, or it is kind of JPG or GIF image, or JPEG image, or NKV video, or any other type of data. It can be a Word file as well, it can be an Excel file as well, or it can be a PDF file as well, or so on. So there are different file types that are available with each and every file that you have. And if you are looking forward to use one of that particular file, the presentation layer is responsible for figuring out what type of file actually you use, or what type of file that you need to format it into, or do the compression over there. And how do you do that? You basically type that particular, or your device will collect the information, and your device will specify that, okay, this is the format that the data can be visible. So when you access the resources of YouTube, there is something like MP4 video, or there is some other type of data that you are accessing over the internet. And presentation layer is responsible for taking decisions on how to represent the data to the user. Makes sense? That's something that presentation layer takes care of. And then you look into something that how session layer can actually be responsible for. So when it comes down to session layer, then session layer is responsible for keeping, you can say, responsible for keeping separate application data apart from each other. You get that? So session layer is kind of responsible for keeping different application data separate from each other, or separate application data different from each other. Well, you can call it however you want. So when we consider these things, then you actually, I would say, need to make it familiar that, for example, let's say that you have a web application. Now, if I consider that this is your web browser, let's say, and then this web browser is using different tabs there. So the first tab is YouTube, the second tab is Facebook, the third tab is Insta, and the fourth tab is LinkedIn. Okay, these are 4 different tabs that you have in your web browser. Now let's assume that the device is using an IP address of 192.168.1.5, for example. And then all these different, I would say, servers that you're accessing, or all these different websites that you're accessing, will be having independent server, correct? So let's say that the server of YouTube is available at 11.1.1.1, considering like random IP addresses. Then the Facebook server is available at 22.1.1.1. Then the Insta server is available at 33.1.1.1, and LinkedIn, or server of LinkedIn, is available at 44.1.1.1. Makes sense? This is how the information is available to you guys. So when you consider that this is how the information is, then can I say that when you are actually communicating from your PC to the YouTube, then the source IP address for this is 1.5, and the destination IP address will be 11.1. Do you understand that? Just like that, when you will communicate with Facebook server, the source, however, will be the same, 1.5, and destination will change to 22. With LinkedIn or with Instagram, the source IP is again going to be same, and the destination will be 33. And with LinkedIn, the source IP address will be the source IP address will be 1.5 and the destination again will be 44. Just a minute, guys. Yeah, hey there, sorry about that. All right, so as we were discussing about session layer, you can say that the source IP is always going to be same and destination IP address will be different for that, right? Now tell me one thing, that whenever these servers are going to solve your query and give you the reply back, because you will be sending the request to each and every server here, and then they will be giving you the reply back. And when you do that, then you actually do it in a way that your source will be same while you send the query, the destination will be different. But in the opposite way, whenever you will be like getting the reply back, then it is going to be the destination IP, the source IP address that is going to be different, and then the destination IP will be same, that will be of your PC. So as the different servers are sending the data onto the same IP address, right? Have you ever seen that your YouTube application data opened up into Facebook tab, or Facebook's data opened up in some other tab, right? Like Instagram tab, or Instagram data opened up in LinkedIn or so? Have you ever noticed that? Does it ever happen? You can give your answers or responses into the chat. Exactly. You won't see that ever, correct? Why so? Because session layer is responsible for keeping different application data separate from each other. Okay, and that's what it does over there. Now all this data, because if we look at I would say these different layers that you have here, then all this data into divided, or the OSI layer itself is divided into different aspects. So when we say that this aspect is called as, or the terminology for that is PDU, and PDU stands for Protocol Data Unit. Okay, so when we collect information about your application, presentation, and session, then the PDU fills up the data or considers that data as raw data. It doesn't give any of the information, or it doesn't give any name to that data, because when we consider application, presentation, and session, then these three layers are called as software layers, which contains or which actually collects information from your machine about the applications that you're using. Then if we consider network, data link, and physical, then all these three layers are called as hardware layers. And this transport layer is called as heart of OSI. Make sense? So when your computer actually collects the data from application, presentation, and session layers, this data will be considered as raw data. And then once the session layer information is collected, Then you actually come down to the transport layer. And then inside the transport layer, when you come down there, then the transport layer will convert the PDU into segment. And at transport layer, the task of identifying whether TCP needs to be used or UDP needs to be used is done. So identification of TCP and UDP is done at transport layer. Make sense to you? So when we say, now let's consider what is the difference between TCP and what's the difference between UDP. Some of you might have heard that TCP is reliable and UDP is not, or so or so. So TCP stands for Transmission Control Protocol, and UDP stands for User Datagram Protocol. Correct? TCP stands for Transmission Control Protocol and UDP stands for User Datagram Protocol. And what are the differences between TCP and UDP? It is treated that TCP is connection oriented, and I'll tell you the reason for that. And UDP is connection less, right? TCP is reliable and UDP is not reliable at all. TCP is slower and UDP is faster. Then there are other characteristics as well, that delivery guarantee is provided into TCP, while in UDP there is no guarantee of data delivery or so. And if we consider the most important factor, then TCP is used for latency sensitive, or you can say TCP used for something, you can say delivery sensitive data. And UDP is used for latency sensitive data. Make sense? And how does it actually works? So it all works with the help of a concept which we call as three-way handshake protocol. Yeah, UDP works in real time as well. But TCP also works in real time. That's none of the thing over there. So it all works with the help of three-way handshake protocol. Okay, now let me tell you what three-way handshake protocol is actually. Let's say, for example, that you want to communicate. You are sitting over here, and this is A, and then you are sitting over here and called B. And for example, say that in a classroom, you are sitting. I'll give you a small short story. So in a classroom, you are basically sitting there with one of your friend, okay, and then that particular friend of yours wants to wake you up or wants to communicate with you, okay, because let's say A has his girlfriend waiting outside the class, but B is sitting with him and B wants to tell him that, hey A, your girlfriend is outside waiting for you. But as A is sleeping, he cannot really listen to any of the informative thing or beneficial thing that B is saying. So how would it ensure that? So how it works is A wants to communicate with B. So what will B do? B first initiates something called synchronized message. And what this synchronization message would be, B will try to wake him up. Hey, A, wake up. There's something for you. And when A wakes up, then A gives the acknowledgement to the synchronization that, hey, B, tell me what is it. And then it will also send its synchronization message that, yes, I have waken up now, I can listen to your messages. and then B gives the final acknowledgement.
धीरे धीरे एक बार पहुंचाएंगे जरा इसको.
Make sense? That is how it is associated, or let's say when that is how A and B will be able to communicate. So when B gets ensured that A is no longer sleeping, then B will give the final message to him. Just like WhatsApp. Imagine you open up the application and you open up a contact of yours. So when you open up that contact, within 1 or 2 seconds, you start to see whether the user is online or not. Correct? Now during that 1 or 2 seconds, until you see that the participant or recipient of the message is online or not, be it your girlfriend, be it your boyfriend, or whosoever, till then your device actually figures out like with the working of three-way handshake protocol, it exchanges some of the messages there, and once it gets assured that the recipient party is online, then the device starts to show you that the user is online. Otherwise the device will print you the last sent data or the last sent time, if it is visible or not. So that is how three-way handshake protocol actually works. Before actually sending a data, it actually initiates, or it actually establishes a TCP connection with the destination. And once the TCP connection is established, then and then only the communication will be started there. Make sense? And that's why we say that TCP is connection oriented protocol and UDP is connectionless, because in UDP there is no such case that happens. That the data will directly be sent and there won't be, I would say, anything that will actually, yeah, there won't be any connection oriented thing or three-way handshake protocol that will be exchanging some of the messages. And as this three-way handshake protocol ensures that the data will get delivered, that's why it is reliable, and UDP is not reliable. And it is slower and faster, and delivery is guaranteed, and there is no delivery guaranteed. Okay, why so? Because if using TCP, it also gives you an ability to use error correction, or there are some other things that are followed into TCP. So when we consider those things, TCP actually uses something called windowing, okay, or something called segmentation, or something called error checking or error correction. And how that? Let's say if you have a message, yeah, SIP actually works there. So let's say that there is a message. Message is, hello, how are you? This is basically a message that A wants to send to B. Makes sense? Now, when this message needs to be sent, actually, depending on the size of the bandwidth, depending on the size of the traffic that can be shared or so, the message will be segmented into different chunks of data. And all these chunks of data will be numbered. For example, random number 101, 102, 103, 104, 105, and like that. Now, when windowing gets done, windowing is a process of figuring out the maximum size of the window that the chunk of data can go. If you have like ever noticed that whenever you initiate a file transfer thing in a Windows machine, then the file transfer utility actually shows that at the initiation it will take 2 hours of time to complete the file transfer. Then on the next instance, it shows 1 hour. The next instance to that, it will show 30 minutes, and then 15 minutes or so or so or so. And the size gets divided, and after some time, you start to like get the real value that okay, it's gonna take 1 minute and 30 seconds, then 29, 28, 24, like that. Correct? Now, till the time it shows real data, till then the device is actually struggling to figure out that what is the size of the window, how much of data can I send so that it doesn't cross the limit of the receiver. So earlier it sends like 10 packets, for example. If they will get successful, then it sends 20, and then 40, and then 80, and so and so. It starts increasing the size of the packet or the size of the packets. Okay, and where it detects failure, then it goes on to the last successful size, and then it keeps on sending the data according to that. That's what is called as windowing. Now, this windowing also follows something called segmentation and sequencing. So as the data will be segmented into different chunks, for example, your window size is 2. So at the initiation, A will send packet number 101 and the packet number 102 will be sent. Okay, and when those packets will be sent, then the receiver actually needs to acknowledge back with the next value or with the next packet. And then it says, okay, I have received 101 and 102, send me 103 now. Then the sender will send 103 and 104. And then the receiver will acknowledge with the next value, which is 105. Makes sense? That is how the sequencing and segmentation actually works. If the device doesn't receive packet number 103 or packet number 102, then what happens? Then at that particular time, the acknowledgement will be sent for 102. And then the device kind of recognize, okay, the packet, the actually the destination received packet number 101, but it didn't receive packet number 102. So it will restructure the next data to 102 again and 103. And then if the destination receives that data, then it will acknowledge with 104 as the next packet or so. And that is how the thing is actually done. Do you understand that? Please acknowledge in the chat. Perfect. So that is exactly how TCP and UDP works over here. And when we say that the transport layer, then transport layer actually does the work of detecting or identifying that whether it should use TCP or whether it should use UDP for the current like communication that needs to be done. And still your data or your device has not initiated the transfer of that particular traffic in order to reach out to that YouTube server. Make sense? So when we specify the transport information, then it comes down to the network layer, and then network layer transfers or converts this segment into packet. And then it adds the information about source IP address, and it adds the information about destination IP address. Okay, and then it also contains the data that is being coming up from the upper layer like TCP and UDP, plus it will contain the data as well, and that's what packet content will be. Do you understand that? And as you know that the devices which actually works with at network layer are routers, because the devices that works with IP addresses are routers, and that's why we call routers as layer 3 devices. Make sense? And once it collects the information about network layer, then it will come down at data link layer, and the packet will then convert from packet to something called frame, and the frame will have content of source MAC address, plus it will add the content of destination MAC address, plus it will have the content of source IP on every other information that is coming from the upper layers, plus TCP or UDP, plus it will contain data. And that's what the content of frame actually will be. Do you understand that? And then at the physical layer, the frame will be converted into signals, or it will be converted into electronic signals, or I would say binary data. And then the data is actually sent onto the cable, and then it reaches out to the server or to the destination by following the routing or following the every other method that it needs to follow. Make sense? So this process that we actually discussed is called something as encapsulation. You get that? And whenever the destination device actually receives the information, then it will does the exact opposite process of something called decapsulation. So it will open up the physical layer, then it will go to the data link, and then it will go to network and transport and session, build up session, figure out how the data should be represented, and then it reaches out to application. And once it reaches out to application, then the data will actually be shown onto your window. So that is how encapsulation and decapsulation is done in OSI model. You understand that? So when we say that OSI reference model is actually something that can be used for reference purposes, but this is not something that is used in our devices, because OSI model came into existence, or when we talk about it, then OSI model actually came into existence in 1984 by an organization called ISO, International Organization for Standardization. And just like that, there was some other model called TCP/IP, which was again brought up in around same year, I would say, but in around late 1970s or early 1980s or so. And that was developed by Department of Defense. And this Department of Defense model, where OSI model consisted different layers, right? 7 layers, which was, if we consider OSI, then OSI had application, presentation, session, then it had transport, it had network, it had data link, and it had physical, right? But the TCP/IP model only consisted of 4 layers, and those layers were application, those layers were transport, okay, then it was network and physical. So the first 3 layers, application, presentation, and session, were equivalent to the application layer of the TCP/IP model. And then transport layer was same as of transport layer, and then network layer again was same as of network layer, and data link and physical was made to physical layer of the TCP/IP. So it still does the functionality of all the 7 layers, but I would say the layers are shrinked down to only 4 layers. Makes sense? And in today's world, the model that we actually use is a TCP/IP model. So we call TCP/IP as logical model because that is something that is used in today's world. And we call OSI model as a reference model, which means we can refer to this model in order to actually understand how the process works of encapsulation and decapsulation. Do you understand this thing? So I hope now it is clear for you how the communication over the internet or how the communication over the network is done. Perfect. Now over here, we'll just take a 10-minute of refreshing break, okay? So that we get our mind fresh, because this has been a lot of theoretical concepts. And then we will move on with the next concept. Okay, perfect. So I'll see you guys exactly in 10 minutes. Till then, stay tuned, don't go anywhere, and we'll be moving on with the next topic. Thank you. Hey guys, I'm back. Hope you are back too. Let's start. Great. Now you have understood how we actually uh, encapsulation, decapsulation thing works. But none of it is possible, or none of the thing is possible if we don't use IP addresses in our network, right? So there are, I would say, a different type of communication that we actually work around with, and the type of communication that we have. One, you have unicast. Then second, you have multicast. And third, you have broadcast. Right? Unicast, multicast, and broadcast. These are the three type of communication that you have, or the communication mediums that you have. Make sense? So when we say unicast, unicast refers to more of one-to-one communication, right? Which means like one PC or one system can communicate with the other system. Then if we talk about multicast, then multicast is one to many communication, like in a group also. And then if we talk about the third type, which is called as broadcast, then broadcast is called as one to all type of communication. You get that these are different type of communication, but these communications are only possible whenever whenever we consider something like subnet or like IP addressing and all needs to be used. Okay, if your system doesn't have any IP addresses, you cannot really make use of that particular communication. My screen is visible. I would suggest you to please rejoin the meeting. However, I'll stop my sharing and I'll share it again. And there you go. So I've shared my screen again. Now, if we say that, as I told you, that the communication is only possible when IP addresses are communicated or IP addresses are configured on your systems. Good. So, in order to see, or in order to be able to figure out that how IP addresses works, then if we talk about IP addressing, then we have been using IP addressing for long, and without IP addresses, no communication will be done. So this is how an IP address looks like, right? 192.8 dot, let's say 32.40. If you look at this IP address, this is a 32-bit IP version 4, okay? And it is in the form of dotted decimal form. Makes sense? It's in the form of dotted decimal. So when you see that, then the IP address can again be divided into 4 parts, and each part can be called as something called octet. You get that? An octet is made up of 8 bits. Cool. So octet is made up of 8 bits there. And the IP address again is, I would say, segmented into different, I can say, classes. So there are different classes, and I can say the ranges are also divided accordingly. Ranges of IP address. So I would say we have class A, we have class B, we have class C, we have class D, and we have class E. Okay. So class A has a range of 0 to 127. Class B has a range of 128 to 191. Class C has a range of 192 to 223. Class D has a range of 224 to 239. And Class E has a range of 240 to 255. You get that? Dotted decimal means that the structure of the IP address is in a way 192.168.10.1. So the values that we are using are decimal values in each octet, right? 0 to 9. And you can see that the screen or the structure or the octets are divided with the help of dot. That's why we call it as a dotted decimal. The values are decimal and the structure is dotted. Cool. So as I told you that this IP address structure is divided across different ranges and different classes of IPs. We have class A, class B, class C, class D, and class E. However, we only use class A, class B, and class C. Only these three classes are publicly available. Class D is reserved for media and multicast use. And class E is reserved for future and military purposes. Make sense? This is how the classification is done for different classes that you have available. And in order to identify that what is the class of the given IP address, you just need to compare the first octet with the ranges here. So if the first octet of your IP address is 192, then you just need to check where does 192 fit in. And as you can see, 192 fit in this. That's why it will be called as class C IP address. Makes sense? This is how it is assumed. If your IP address is something called 72.11.23.71, then what will be the IP address? What will be the class of the IP address? It will be class A. Makes sense because 72 comes into the range of 0 to 127. Just like that, if you have an IP address called 172.16.0.1, then this will be class B IP address. So this is how classification of IP address is actually done. So whenever the manufacturers actually came with the ranges, then it was actually standardized that you cannot actually use class D and class A. So there is no information that I can actually give you regarding those. But yeah, I would say that the ranges are, I would say, reserved, and the information regarding that is not disclosed that much. So you can consider that we will be only discussing about class A, B, and class C. Now, in order to understand the IP addressing in a much better fashion, what you need to do is you need to learn how to convert the IP address into binary. So something we call as binary conversion. Cool. And this binary conversion needs to be learned here. So when we say how binary conversion can actually be learned, let's consider an IP address 192.168.32.40 because binary is whatever computer understand. A computer doesn't understand anything in decimal or so. So when you enter an IP address, it actually converts that IP first into binary and then like uses that IP for the communication purposes. Make sense? So like this, what we are going to do is we will take each and every octet separately, be it 192, 168, 32, and then 40. And then we will convert that IP address into binary by using our master formula. And that master formula is 128, 64, 32, 60, 8, 4, 2, and 1. This is what the master formula is. And what you need to do in order to come up with the outputs or with the binary conversions is select the octet, because what this is nothing but you can say 2 to the power 0, 2 to the power 1, 2 to the power 2, 2 to the power 3, up to 2 to the power 7. So 2 to the power 0 is 1, 2 to the power 1 is 2, and 4 and 8 and 16 and so on. 2 to the power 7 is 128. That's how the values are actually divided. You get that? And these are all 8 numbers. So you have 1, 2, 3, 4, 5, 6, 7, and 8. You have these 8 numbers there, and each number represents the specification or represents the location of 1 bit in every octet. So how you do the calculation or how you do the conversion is pretty easy. What you need to do when you know about the dotted decimal, or when you know about the number that you actually want to convert into binary, which is for us, I would say 192, then you need to look for that value inside this formula. Do we have 192 over here? So you look for that value directly into the master formula. Do we have that? No, you don't have that. Right? So what will you do? If you don't have that value, you figure out the numbers by adding which you can actually get that value. For example, if I add 128 with 64, what will be the output? 128 plus 64 is 192. So that's how I come up to the result. As I have got that by adding the first and second bit, I can get the result as 192. So whatsoever bits that I can add in order to get the desired result, those bits or those numbers location will be set to 1. So when I say 1 and 1 for 128 and 64, then the result will be 1 1, and rest of the 6 digits 1 2 3 4 5 and 6 will be 0, like that. This is pretty easy, right? Let's say if you want to figure out the number for 168. Now 168 also is not available in our master formula, it's not there. So what you need to do, you need to come up with values that by considering which uh, you can actually figure out the binary bits. So if I say I can add 128 plus 64, but you cannot do that, right? It will cross the value and it will become 192. So what do? You skip 64. Then you go to the next one, which is 32. If you add 128 plus 32, then how much it becomes? 160, right? Still it is less than the desired output. So how much more do you need? 8, right? So you cannot take 16, but you can take the next 8. So you say plus 8, and then the output becomes 168. Now how many values did you take? You took 128, you took 32, and you took 8. So you set 128 as 1, 32 as 1, and 8 as 1. And rest of them will be 0. So the binary becomes 101010000. You understand that? Yeah, just like that, if you go for 32, 32 is directly available there, right? So you say 00100000. Only third location will be enabled. And for 40, it will be the combination of 32 plus 8. That becomes 40. So you say 00101000. And that's how you come up with the binary of 192, 168, 32.40. And you say 110 000 dot 10101 000, and then 0010 000 and 001 01000. This is the binary conversion for 192.168.32.40. You understand that? Makes sense? That's how the thing actually works here. Now what I'm gonna do, I'm gonna give you certain IP addresses, and you need to figure out the binary conversion for those IP addresses and see if you're comfortable doing that. So the first IP address that I'm giving you is 157.212.73.97. That's the one. That's the first IP address. Then the second IP address that I'm giving you is 113.169.83.211. You get that? Then the third IP address is 74 dot, I would say 91.183 dot, again 53. And then the fourth IP address, which is the last one, is 232 dot, 171 dot 71 dot 145. These are the four IP addresses that you need to convert into binary. So go ahead, take 10 minutes or take 5 minutes of time and see if it works for you. And I'll be here to resolve your questions. Feel free to ask. Yeah, all right. Most of you have already figured out the things. So I'll just review the same for you guys. I hope you all can see my screen now. And what I'll do, I'll take each and every IP address one by one, and I'll consider the same. So if we talk about the first IP, which is again, let's take the first IP address, which is 157.212.73.97. So if we consider 157, 157 is addition of 128 plus 16, okay, plus 8, and it becomes then 152 plus 4 and plus 1. So this is how you become 157, or this is how it becomes 157, right? So the answer for this is going to be 1 0 0 1, then 1, then 1, and then after that 1 0. No, it's gonna be, yeah, 1 0 1, like that. So you have 128, then you have 16, 8, 4, and 1. That's how you come up with 157. Then in order to come up with 212, 212 can be achieved with 128, then 64. And then after that, you can achieve it with 16 and then 4. That's how you come up with that. So the answer for that will be 110111100. Correct? For 73, it will be something like 64 plus 8 plus 1. So you're gonna have 0 0, oh sorry, 0 1, and then 0 1 0 0 0 1, like that. Or yeah, this is kind of a wrong one. I would say 0 1 0 0 1, and then 0 0 1. Yeah, that's how you come up with 73. And then 97 will be pretty simple. It's gonna be 64 plus 32 plus 1. So you can say 0 1 1 0 0 0 0 1. That's how the output you become. It becomes for 157 212 73.97. Makes sense? You can match up your answers with this. Yeah, 212 is 128 plus 64, and 128 plus 64 becomes 192. Then plus adding 16, it becomes 208. Plus adding 4, it becomes 212. So for that, it will be 110. Ah, I have did something wrong here. So this will be 110, and then 1, and then 0 1 0 0. That's how it will be. Yeah, 212 is corrected, and that's how the configuration, or that's how the thing would look like. So you can think about other domains over there, how they can be actually configured there. And yeah, that is so. Usually when we talk about, or even if I say, or when we even keep these things, so when we look at the classes, the class actually starts at 0 and it ends up at 255, meaning if you have any IP address, then any octet of that IP address cannot cross 255. You need to have a value which is lower than 255 there. Makes sense. I cannot have an IP address that starts at 300.12.0.1, right? Or I cannot have an IP address that says 192.168.1.270. This cannot be any IP address. This is all wrong IP address. And if we consider an IP address of any class then that particular class IP also doesn't like takes you beyond 255. But why so? Because there is binary requirements or binary conditions there. So when we say that the minimum value that you have, the minimum value with the binary that you can have can be all zero for all octets. So this is what you can have. And maximum what you can set is all ones. So when you have all zero, the decimal is going to be zero itself. But when you have all ones, then you will be adding every digit that is mentioned there. So 128 plus 64 plus 32, 16, 8, 421. You will be adding everything here. And the addition of that will become 255 as a result. Makes sense? That's why you do not have any IP address that goes beyond 255. That's the limitation over there. You get that? And this is exactly how it works here. Also, if we talk about class A, so there is an exception with class A that when you consider an IP address or consider the range of class A starts at 0 to 127, but the usable range in class A is only till or only from, you can say, 1 to 126, because 0 is reserved and 127 also is reserved. And why so? Because 0 is reserved for the purpose of default routing and some other purposes, and 127 is reserved for loopback addressing. You get that? These are some of the purposes why these addresses are reserved. Cool, do you understand that? So it is only with class A that you cannot use the complete addressing scheme of class A. You can only use from 1 to 126 there. And now, as this is how IP addressing actually works. So I hope you understand that. Loopback is actually an IP address which is used for the virtual interfaces of every system that you can have. So if, for example, there is a PC and that PC is connected with some other systems or some other, let's, hub, and that hub also has also PC or different PCs connected. So if this cable is break, or if this like network interface card is working or not, in order to check what is the issue, then in that particular thing, you can use go to this PC and you can try to ping your loopback interface 127.0.0.1. And if this ping is successfully done, then it means that there is no fault into the NIC card and NIC card is all good. There is an issue in the cable connection here that you are doing. So loopback interface is for troubleshooting the local interface that you have onto the PC. However, about default routing, we'll be talking about that in the coming sections. Okay, yeah, local hosts also use default addresses. But yeah, so that was the section that we had to cover about the basic IP addressing. Now, the important or more important part that we're going to talk about is subnetting. So, to begin with, now this is the most or one of the most important topics that you will have in your networking journey. Okay, you need to be way good than you are in subnetting, and practice is the only thing that is going to make you even perfect in subnetting, according to my experience. So I would say, request you to pay your attention here as we discuss subnetting. So as I said, the only public classes that we use is class A, it's class B, and class C. And class A uses a range of 0 to 127. Class B uses a range of 128 to 191, and class C uses a range of 192 to 223. And each of this class has certain limits there. Okay, and these limits, or I would say these classifications, are done with the name or with something that is called as prefixes. So there are two type of prefixes. One is called as network prefix, and the other is called as host prefix. One is network prefix and the other one is called as host prefix. So when we look at class A, then class A has its prefix range like this: network, 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 host. And class B has its range as network, network, host. Oh, sorry, that's kind of a wrong one. Class A has its range as network, host, host, host. Class B has it as network, network, host, host. And class C has as network, 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 and host. And then the default subnet mask, if we consider that, is 255.0.0.0. Class B has a default mask of 255, 255.0.0, and class C has 255, 255, 255.0. You get that? This is how the requirement is. Now, what is this network prefix or the thing that I have mentioned there? So when you look at this, then it can be understood in a way that, let's say you have a network that gives you the ability 192.168.1.0. This is the entire network, and the number of IP addresses that you can have starts from 1.0, 1.1, 1.2, 1.3, so on. It goes till 1.255. So you can say that the total number of IP addresses that you have is 256, right? Now assume this as compared to one of the examples that I can give you here is there is a classroom, and in that classroom, let's say that there are 90 benches. Okay, and these 90 benches are occupied by only 60 students, which means you still have 30 benches that are vacant in the class. Just like that, out of the total network that you have, which is 192.168.1.0 network, you have 256 IP addresses, out of which there is a local area network which is being created, and for that local area network, only 100 people are using that local area network that you have. Makes sense? And the IP addresses that they're using is between 192.168.1.0 till 192.168.1.100. These are the IP addresses that are being used by the number of people that you have in a network. Now tell me one thing, that as these guys are connected into a local area network, would they be able to communicate with each other without any routing or so, just by having the IPs in the network? Yes, no? Would these 100 people be able to communicate with each other? Yeah, perfect. So most of you are saying yes, right? And that's correct. They should be able to communicate. Now tell me one thing, that out of these 100 people, let's say that there is a user who has an IP address 192.168.1.43, and this 192.168.1.43 user changed its IP address to 192.168.1.143. Makes sense? Which means that 43 now became vacant. So will this newly configured IP address user be able to communicate with the other 99 users? Yes, no? Some are saying yes, some are saying no. There is no routing that is done yet. So see, the answer is that the user will still be able to communicate with each other. Okay, the user who has changed his IP address to 192.168.1.143 will still be able to communicate, because we have not changed the network prefix of that particular IP address. So when I said that the network that you're using is 192.168.1.0, right? Which means it's a class C network. How many network prefixes do you have? 3. How many host prefixes do you have? 1. So which means that in order to be able to be into that same network or be into the local area network, the IP address that you need must have its first 3 octets into the same network that you have, like 192, 168, and 1. They get that? Then and then only you will be able to communicate with the other users or with the other people that are there. You get that? And as this user changed its IP addresses last octet from 43 to 143, so it will not be any problem for it to communicate with each other. You see that? Just like I gave you an example of this classroom, that there were 90 benches and only 60 were user. So the scenario was being specified in a way that only like one guy from that 60 students like stood up and he changed his bench to to some vacant bench, but he still is available into the same classroom, right? If I say that this is a classroom and then that classroom has 90 benches, and out of that only 60 students are available, so I can say bench number 1 to bench number 60 is being used by these 60 people. Now what I'm saying is the guy 43 wake up and change the bench number from 43 to bench number 83. So what did he do? He will still be able to stay there in the classroom and he will be able to attend all the lectures that are being conducted. Make sense? Just like that, when I have the entire network of 192.168.1.0, I have network prefixes as this, and then the last octet is host. So what I need to ensure that my first network octet or my first network bits needs to be same. You get that? And if I am out of the available IP addresses from 1.0 to 1.255, only 100 are being used, which are 1.1 to 1.100, let's say. Still, you have 1.101 to 1.255. All these IP addresses are vacant as of now. Make sense? So if a guy who has 192.168.1.43 changes his IP address to some of the IP address over here, which is 192.168.1.143, then he still is into the part of the network. He still is in the same local area network there. You get that? Yeah. Now, if the same guy changed its IP address to something like 192.168.2.43, now will he be able to communicate with the rest of the 99 guys? Exactly. Now that particular user will not be able to communicate with the other guys, because what he did, he changed the network prefix, he changed the third octet of that particular IP address to 2, which means he is no longer part of that particular network. Make sense? That's how it works. So the only condition over here that I'm specifying, that in order to stay in a local area network, or in order to be able to communicate with the other users without implementation of routing, you need to have your IP addresses as the same, like in the same network as the other user. If that particular other user, like there are two PCs, and these two PCs want to communicate together. And if you have an IP address like 192.168.1.1 here and 192.168.1.10 here, then you guys will be able to communicate together. Success. But if on the other end the IP address is 192.168. I would say 2 dot something 2.10, then this particular IP address will not go and it will be unsuccess. Make sense? Because the first 3 octet which actually should match doesn't really matches. They are different. I hope you guys understand now. Yeah, good. So that is how the prefixes actually work. And with keeping that in mind, you have different subnet masks as well that are dedicated to uh, each and every class that you have. So you have a subnet mask of 255.0.0.0 in class A, then you have 255.255.0.0 in class B, and you have 255.255.255.0 in class C. Makes sense? And when you have that, then you can consider, for example, tell me one thing now. If you have a requirement of something, like you have an office requirement or office scenario, that you need to create 5 different networks. And in each network, there should be 30 users or 30 users per network. This is what the scenario is. So how will you configure these networks? Which means that you have this one network in which there is going to be 30 users or 30 computers. This is the second, I would say, network in which you have 30 users. Then you have the fourth network or third network, which is 30 users. And then you have this fourth network, which again has 30 users. And the fifth network, which has 30 users again. Make sense? Yeah. So when you talk about this, then how you can design these networks, because these networks should not be able to communicate with each other. No intercommunication is allowed. There shouldn't be any intercommunication that needs to be done. So if you think of a normal scenario, then you will kind of configure 5 different networks, and those networks might be in a way that 192.168.1.0 might be the first network. The second network that you might take can be 192.168.2.0. The third network might be something like 192.168.3.0. The fourth network might be 192.168.4.0. And the fifth network will be 192.168.5.0. These can be the 5 networks that you would think of. So you'll get 1.0 here, you'll get 2.0 here, 3.0 here, 4.0 here and 5.0 here, so that no one gets able to communicate with each other, as the network prefixes of the third octet will be different. Correct? Now in this scenario, can you tell me how many IP addresses are we using from each network? From each network, we only use 30 IP addresses. And how many are we getting? Each network has a capacity of using 256 IP addresses. You get that? So if we look at the total waste that you have, that waste will be 256 minus 30. It will be around 226 IP address will be wasted per network. You get that? If this is the scenario. So for such scenario, how do you use subnetting? There comes the part of subnetting. So what do? You actually take the entire network and then you divide it according to your requirement. Because if you are using that 30 IP address, we cannot say that the remaining 226 IP address can further be used in some other network, because that will be conflict of IP addresses then. You cannot use same IP network into two different network environments. That will be conflict of IP addresses there. So when you have such scenario to be implemented in this way, then the way you communicate or the way you organize your network is by dividing this network into different sub networks. And this is exactly the process that we call as subnetting. You're taking the entire network and you are dividing it by making it as act as a subnetting. Make sense to you? So let's talk about the why do we actually need subnetting. Yeah, what I'm saying, that I'll repeat it one more time. No, not an issue there. So consider this scenario. As I told you, that you have an office requirement where there needs to be 5 networks and there needs to be 30 users per network. So when we say that you actually need 5 networks and you need to use 30 users per network, in that case, you might think of using these 5 networks: 1.0, 2.0, 3.0, 4.0, 5.0. Now in this each network, there is one last octet which acts as host prefix, which means you can assign different host prefix to different IP addresses. And in that scenario, you will be using only 30 IP addresses from each network. And the total number of IP addresses that you're getting is 256. So how many IP addresses are going waste? If we say the total IP minus the used IP, then you are wasting around 226 IP addresses there that will actually not be used in any of the scenario there. Cool? So whenever you have such scenario, then what do? Because the main purpose is not to let the other networks or not to let the different networks communicate with each other. And for achieving that, what do is you divide that particular major network into different parts of the network. Just like if you have purchased an entire floor of a building, and that particular floor can actually vacant around 1000 people. Let's say that this is a floor, or I'll use a pen. Yeah, this is a floor that you have purchased, and this floor has an ability to host 1000 people. Make sense? Now, you have 4 different departments in your company. One is sales department, the other one is marketing department, then the other one I would say is admin department, and then you have an HR department. So when you want to divide this floor in these like around 250 people each department, then you will make a partition in this floor like this, right? So this particular section, sales people will sit over here, marketing people will sit over here. You can say that HR people will sit, and here admin people will sit. Just like that, same thing will happen with the network as well. If you have a major network which actually provides you around 256 IP addresses, then you need to assign different IP addresses to different departments, right? So for example, if you want to divide it equally, then you will assign 64 IP address here, 64 IP address here, 64 here, and 64 here. Instead of using for different networks like 1.0, 2.0, 3.0, 4.0, you use just 1.0 and you divided that big 1.0 network to smaller 4 different networks. That is the concept of subnetting. Do you understand that? Perfect. So for our same requirement, what we are going to do is the office scenario that I gave you. In that scenario, what we are going to do is we will only use one single network, and that single network is 192.168.1.0. Now there is another term that is used, and that particular term is called as CIDR. And CIDR stands for classless inter-domain routing. Classless inter-domain routing. What is this classless inter-domain routing? This is like a number which is represented by using slash notation. So when you have the subnet masks that are listed, then if I just convert the subnet mask, which is, let's say I'll take 255, 255, 255.0. So CIDR actually represents number of network bits in your subnet mask, which means that if I have this subnet mask and if I convert this into binary, then can I say that as I have 255, it means that all the octet from all the bits from my master formula is set to 1. Like this is how the binary subnet mask it will look like. Correct? This is the binary conversion of the current subnet mask that I have given. So when we consider this subnet mask is the default subnet mask for class C, which actually has 3 octets for network and 1 octet for hosts, right? So we can say that this is network, this is network, this is network, and that is host. So you need to actually look into the subnet mask and figure out that how many bits are dedicated for the network prefix. Can you tell me how many bits are there for network prefix? 24, right? You have these 8, these 8, and these 8. So that's why we will refer to the subnet mask in a short form called as /24. So when you see any subnet mask that has, or when you see the default subnet mask of class A, the CIDR value for that can be /8, because it will only have 1 octet dedicated to network prefix which contains 8 bits. When you look at the second one, then class B has a CIDR value of /16. And then the class C will have the CIDR value of /24. You get that? This is how the CIDR values are used. And the CIDR values is the simplest form of representation that you can have for your network. Cool. Now let's go and see how the subnet mask actually can be brought up. So the network that we need to work with is this. We want to work with a network called 192.168.1.0/24. This is the network that we have been provided of, and we need to create 5 networks out of this, each with 32 hosts. And again, considering the Brahmastra that we call it in India, or the master formula, you can say this is how it looks like. Make sense? So when you do subnetting, in subnetting, there are certain things that you need to take care of. That 4 things that needs to be calculated. The first one is number of networks. The second thing is called number of hosts. The third thing is called as number of the third thing is called as subnet mask itself, and the fourth thing is called as ranges, or you can call it as block sizes as well, or blocks of networks as well, whatever you want it to be. So when we say that these are the 4 things that you need to calculate, the number of network can be calculated with a formula called 2 to the power number of borrowed bits. And I'll explain you what is called as borrowed bits. The second thing is 2 to the power number of off bits. Then you have subnet mask, and then you have ranges. Make sense? Now, as you see, we need to figure out these values for /24. So the first step is to write down the CIDR into the binary form in order to make it easiest. Okay? So when we have /24, what will be the binary form? Binary form will be 11111111, and then all zeros. You get that? So when you have this, it means that the first octet by default is dedicated to network, the second one is dedicated to network, and the third one is dedicated to network, and the last one is dedicated to host. Correct? Now pay attention over here, because this is a crucial part. When you make changes into the host prefix, that you attempt to convert these host numbers into network numbers. For example, this is the default one, but you create a new subnet mask, or you create a new CIDR value where you are changing the host prefixes from all zeros to this. So what you did, you changed first 2 bits from the host prefix into network bits, which means you borrowed the first 2 bit from the network prefix, from the host prefix, and you converted that into network. And those will be the bits that we will call as borrowed bits, which means the number of bits that you make change into host prefix will be called as borrowed bits. Do you understand this? Currently, we don't have any borrowed bits in our network. Make sense? Currently, we don't have any borrowed bit. So that's why the formula for figuring out number of network will be 2 to the power 0, because number of borrowed bits is 0. We have not converted any host prefix into network prefix yet. So we say number of network is 2 to the power 0 there. And what will be the output? 1. So we just have one network there. Then you need to figure out number of off bits. Off bits means number of zeros in your CIDR. How many number of zeros do you have? You have 8 zeros, correct? 8 zeros you have, not 6. So that's why we will say number of hosts is 2 to the power 8, and that will kind of give you 256 number of hosts in one network. You get that? And the subnet mask for the same will be just the I would say dotted decimal conversion of the CIDR, which will be /24 means 24 on bits. First 8, second 8, and third 8. And then the last octet will be 0. You get that? And then the range will be in a way that you will start the network from the 0. So you will say 192, 168, 1. This is going to be constant, right? As the part of the network prefix. And you will start from 0, and then you will end up at 192.168.1. The last IP address will be 255. And totally you have 256 IP addresses, and in each network, like you have the number of network as 1. Make sense to you? And there is also a term called valid hosts. So valid hosts is equal to number of hosts that you have minus 2, which means valid host will be 256 minus 2, that is going to be 254. Why so? Because first IP of every network is called as network ID, and last IP of every network is called as broadcast ID. Do you understand that? First IP address of every network, which means 192.168.1.0, will be reserved as network ID, and 192.168.1.255 will be reserved as broadcast ID. So the usable IP address will be from 192.168.1.1 to 192.168.1.254. That's the range that is gonna be. Hope you understand that. Perfect. Now I'll give you another example to understand subnetting even much better. Let's say that as we have the number of network as 5 requirements, right? And the host as 32. Let's consider the same thing, because this is what we have just figured out the numbers as default ones. So I'll now consider our requirement, and based on that requirement, I'll come up with the formula. So again, we get provided with the network that is 192.168.1.0 slash 24, right? And we have 5 networks, and we have 30 hosts. Good. And then I'll write down the master formula: 64, 32, 16, 8, 4, 2, and 1. Make sense to you? Now over here, what we need to figure out, the first thing is, again, number of network. The second thing is number of host. The third thing is subnet mask. And the fourth thing is ranges. Now, the very first thing that we do is write down the CIDR into binary again. So we will have a CIDR of, or the subnet mask of this. Network, network, network. And then you will have host as these heads. Make sense? Now what is happening here is you have a requirement of 5 networks. Now if you have your host prefix as these and your network prefix as these, then have you borrowed anything? You have not borrowed anything. That's why the number of network will just be 1 there. But if you want 5 networks, then you need to select the value for the number of network that you can cater based on this formula. You cannot directly get the value that is 5. You can get a value in this range. You can get 1, 2, 4, 8, 16, 32, 64, 128, and so on. So what will be the nearest value from the formula that is like that covers your requirement? Can we go with 4? We cannot go with 4, right? So what will be the nearest value that you can come up with? The nearest value for 5 networks is 8, right? You cannot go with 4. So the nearest value can be 8 networks. Make sense? Now in this case, you have selected 8 here. And what is this 8? This 8 is 2 to the power 0, 2 to the power 1, 2 to the power 2, 2 to the power 3. 2 to the power 3 is equal to 8. And when you figure out that the power of your chosen value is 3, it means 3 is the number of bits that you will borrow. Again, understand it. Are you good selecting the nearest value based on the requirement? If your requirement is 3 network, you will go with 4. If your requirement is 5 networks, you will go with 8. If your requirement is 10 network, you will go with 16 network, because you need to select a value that goes into the power and not normally of that. Make sense? And for that, as you figured out that 8 is going to be the number of network for you, which means that 8 is 2 to the power 3. And when you get it, that 3 is the bit, it means that you need to borrow 3, I would say, first bits from the host. So you convert these first 3 host bits into network bits. And now the last octet will become 111, and then the remaining 5 will become 0. Which means that from the entire host portion, you divided that host portion into 2 portions. It became network, and then you have this as host. Are we good here? Perfect. And this specifies that the number of network for you is going to be 2 to the power 3, which will give you 8 networks. Cool. And then what is the value for number of hosts? Number of hosts is 2 to the power number of op bits. How many op bits now do we have in our entire CIDR? Can I say 5? 2 to the power 5. And that gives you 32 hosts. Make sense? This is how you come up with number of network and number of hosts there. And then the subnet mask. Now the CIDR value, as you have modified it, changes from /24 to /27. You get that? Because now the total number of on bits is not 24. The total number of on bits have become now 27. That's why for /27, the CIDR will be 255.255.255. These are the first 24 bits. Then you need to add the first 3 bits from the master formula. And 128 plus 64 plus 32. So you say 224. Do you understand that? Great. So you can see that one formula can help you in many different ways. You need to just use that again and again. Cool. And then how would the ranges be divided in this? The ranges will be divided in a way that, yeah, I'll explain it again, Vaibhav. So see, as of now, what you have is /27 is how you have figured it out. That /27 is the CIDR for your requirement. Is it good with you? Weber, please reply. So when you need to figure out the subnet for /24, you just need to convert it into binary. So when you have the binary for 27, it would look like this: 8, 8, 8, and then 1, 2, 3, and then like this. So if you want to convert this octet into dotted decimal, then you just take the help of this, like 128, 64, 32, 16, 8, 4, 2, and 1. And you just put your values inside this formula. How many bits do you have on? Everything, right? All the 8 bits. So you just add everything. And that becomes 255 over here as well, over here as well, and over here as well. Now from the last octet, you just have first 3 octets that are turned on. So you will only add first 3 octets from this: 128, 64, and 32. And that will become 224 as the subnet mask. Hope you understand that. Yeah, if you borrow, I will explain that, Amar, don't worry. So this is how it works for you, okay? And then you will start writing down the ranges. Then the ranges will be starting from 192.168.1.0, and it will end up at containing 32 hosts. 192.168.1.31. It will not end up on 32 because we are starting with 0. We end up at 31. Then the next network will start from 192.168.1.32, and it will go till 192.168.1.63. Then 1.64 to 1.95, 1.96 to 1.90, to 1.127, 1.128 to 1.159, and 1.160 to 1.191, and 1.192, wait, yeah, to 1.223, and 1.224 to 1.255. How many networks are these? 1, 2, 3, 4, 5, 6, 7, 8. Do you see that? Totally, you have came up with 8 networks, and each network has 32 hosts inside of it. What will be the valid host? The valid hosts will be 30 according to your requirement. Do you understand that? So every network that you have, 1.0, 1.32, 64, 96, 128, 160, and so on, so all these will be the network IDs, and all of these will be the broadcast IDs. Do you understand that? Yeah, that is exactly how you do subnetting there. Make sense? I hope most of you understand this thing. And those who do not understand it, yeah, the range is just the combination of number of hosts that you have. If you have 32 hosts, then you start at 0 and end up adding 32 into it. Then start with the next one, then end up adding another 32. Like that, you just figure out for the number of networks that you have. And as our requirement is there, we will only be using the first 5 networks. So we will be using this, and this. These are going to be the 5 networks that we will use. 1, 2, 3, 4, and 5. And the remaining 3 networks will still be reserved for us. Those are kind of the empty, I would say, those are kind of the empty networks or empty floors or empty cabinets. You can assign values there later. Amar, this formula, someone is posting into the chat that you didn't understand this. So this formula that we have, 128, 64, 32, 68, 4, 2, and 1. This formula is nothing but 8 different values in an octet. Okay? The first value is 2 to the power 0. Second value is 2 to the power 1. Third value is 2 to the power 2. Fourth value is 2 to the power 3. 4, 5, 6, and 7. Make sense? And as we have 5 networks, the nearest value is 8. So when we choose 8 as the number of network, the number of network actually can be written down in this way, 2 to the power 3. You understand? And that's how we reserve 3 bits there. Hope you understand that now. Exactly. Now what I'm going to do, I'm going to post up some, I would say, exercises here. So go ahead and see if it works for you. What you need to do now is, for me, you need to do this exercise. Figure out all these 4 things for 2 networks, 192.168.1.0/25 and do it for 192.168.1.0/26. Try to figure out the things for these 2. Okay, figure out number of network, number of hosts, subnet mask, and ranges, and the valid hosts for both of these, and see if it works for you. Okay, I'll give you 20 minutes and let me know if you're done with that. Don't post your question or don't post your answers when you're done. I will give you time enough, and then when I say that please post your answers, then you are free to post. Let everyone take some time to digest the things. Okay, thank you. Hey there. So yeah, people have started putting their answers into the screen or into the chat section, and I can still see that slash 26. So you guys can start putting your answers in the chat, and I believe we are good with what we have done. Okay, I see most of you are. So I'll write the answers here. That for the first network, I'll divide it into two. For the first network, which is 192.168.1.0/25, the number of network, the number of host, the subnet mask, and ranges will be according to 2 to the power 1 will be the number of network, because 24 and 25 we just borrow one host, right? So number of network will be 2, number of host will be 7, because if we keep 1 bit off, 7 will be off. 1 bit on, 7 will be off, so that's going to be 128. So you'll have 2 networks, each of 128. Then the subnet mask for the same will be 255.255.255 dot 128. And then the ranges will be, the first network will be 192.168.1.0 to 192.168.1.127. And the second network will be 192.168.1.128 to 192.168.1.255. That will be slash 25. If we talk about 192.168.1.0 slash 26, then the number of network, number of host, subnet mask, and ranges will be accordingly. Number of network will be 2 to the power 2, which is 4 networks. Number of hosts will be 2 to the power 6, 64. Subnet mask will be 255.255.255.192, and the ranges will be from 192.168.1.0 to 192.168.1.63. Then 192.168.1.64 to 192.168.1.127, and 192.168.1.128 to 192.168.1.191, and then 192.168.1.192 to 192.168.1.255. That's what the thing will be. Okay, and I hope most of you are correct over there. You can verify your answers with mine. Well, my screen is visible, I believe. Yeah, I just confirmed that my screen is visible. So you can verify your answers by yourself. Okay, and I'm giving you an assignment that you need to, I would say, you can treat it as kind of homework thing. So you need to do 192.168.1.0 slash 27 slash 28 slash 29 for the same IP. These three are going to be your homework thing, or you will also do slash 30. Okay, these four are going to be your homework thing, and we will keep it as that only. So I hope you kind of are enjoying the session, and I hope the session has been pretty good for you. Even though that most of you were communicating that you guys are looking forward for any WhatsApp group also, but we don't have any WhatsApp group, we have a Telegram group, and I believe most of you have joined me in the Telegram group there itself. So I request you to join the Telegram group, and I will also request you to follow me to follow us on my Instagram handle and as well as my LinkedIn handle. Also, do follow me. Do follow our company page on the LinkedIn. Okay, and I believe the link for that can be found there. You can just search for Abhijit on Telegram or on LinkedIn, and the company name can also be searched as PyNet Labs on LinkedIn. So I request you to please follow us so that we can spread this free CCNA classes to more of the needy ones just like you. And as it is helping you some or the other way, it might help to some other people as well. So it's a request to all of you to please go there and follow us. And I hope you enjoyed the session. And I'd like to thank you for tuning into today's session. I'll see you guys tomorrow on the same time. Till then, the recording will be uploaded into the Telegram group. Okay, so please go ahead and do practice the session that we had today. And I hope you enjoyed it. Thank you so much for tuning in. The rest of the questions, you can please ask us there on the Telegram group, or you can reach out to the Panshu or me or the company via LinkedIn follow. So I request you to please follow us. That's the only thing we can ask so that we can reach out to more and more people and can share this knowledge with the needy ones. Thank you so much for tuning in. Take care of yourself. I'll see you guys tomorrow on the same time. Bye-bye.